Hello, modern math students. Just recording this lesson for you guys on the Pythagorean theorem, which is part of the unit on the geometry that we've just entered into. So I'm going to do a recording, ask that you guys watch this, and then work on some practice problems that will definitely prepare you for the actual final exam, which I'm also going to email to you guys shortly. So where did it come from? That's a good question, right? It's the Greek Pythagorean. Pythagoras actually came up with a concept that is used specifically when dealing with right triangles. It speaks to the relationship between the legs of the right triangles and the hypotenuse being the longest side of the triangle, which is here. It's always directly across from the right angle. So that's how we know the hypotenuse. Basically, the hypotenuse is equal to the sum of the square of the legs. The hypotenuse squared, which is c squared, is equal to the sum of the square of the legs. One particular triangle that we know is the 3, 4, 5 triangle. If the leg is 3, the other leg is 4, that will give us the hypotenuse squared of 5. So how do we know this? If we do 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 and 16 added together would give you 25. So this is what we call a Pythagorean triplet. And we're going to come back to that a little bit later in the recording. But it's just something that I always use to illustrate how the Pythagorean theorem works. So, prior to Pythagoras, the Egyptians had sort of been the first ones to pilot this, or to really have an understanding of how the sides are related in a right triangle. They related it to the 3, 4, 5 triangle. And that was way before Pythagoras. Pythagoras was a Greek, but the Egyptians were really great mathematicians. They were just phenomenal when it came to mathematics. But Pythagoras sort of generalized it and developed it and made it more concrete, where it was accepted, worldwide. So basically, it's the sum of the square of the legs, a squared plus b squared equals c squared. The legs represent a and b. Doesn't matter which value you plug in for a and b, but what matters is what you plug in for c, which is the hypotenuse. So here's the hypotenuse, which is c. This is the side opposite the right angle. Always opposite the right angle. That's what makes it the longest side. And then you have side A and B. Let's just take some of this off. There are certain sets of numbers that have a very special property. And these are what we will look at next. These are the triplets, or the Pythagorean triplets. So we talked about the 3, 4, 5 triangle a few minutes ago. And of course, any multiple of all 3. So if you multiply each of these by 3, you get another Pythagorean triplet of 9, 12, 15. That would also work if you did 9 squared plus 12 squared. That would be equal to 15 squared. So any number that you multiply this triplet by will produce another Pythagorean triplet. So if this side is 9 and this side is 12, we would plug to find c. We would do 81, which is 9 squared, plus 12 squared equals c squared. So 9 squared is 81. That's 9 times 9. 12 squared is 144. And then when we add them together, 81 plus 144 gives us 225. That value is the value of c squared. So in order to find just c, we want to take the square root of 225, which would be 15. You can use your square root, your calculator, to find the square root of any number. So if you use your calculator, the basic function, the basic square root function is there. You can certainly use your calculator for that. All right. Okay. Here's another example. Let a equals 6, b equals 7, c equals 11. So we're going to see if this works for a right triangle. So it would be 6 squared plus 7 squared. And we'd see if that equivalence um, 6 squared is 36, 7 squared is 49, 11 squared is 121. If this equals, then we know it's a right triangle. 36 plus 49 is not equivalent to 121. In fact, 36 plus 49 would give us 85, which is not equal to 121. So the answer is no, it's not a right triangle. Okay. So now let's look at this question. We have 26 for the hypotenuse, 10 and x. So we're trying to find x. So a squared could be 10 squared. B squared would be x squared. We don't know what x is. And then equals 26 squared, the hypotenuse squared. 10 squared is 100, and x squared. And then 26 squared would be, just do a quick computation here, 676. So now we're going to subtract 100 on both sides to form x squared. That becomes 576. And then we're going to take the square root of 576 to give us x. Which is 24. 24 times 24 is 576. So our answer would be x equals 24. I'll let you guys mull over that for a minute. This one we're going to add, so it'll be 12 squared plus 16 squared. It'll be 144, and then 196 equals c squared. And that sum would be 144 plus 340. And that would be the square root of 340 to give us c. This should be 256, I'm sorry. So it'll be 144 plus 256. and that gives us c equals c squared is 400. C would be the square root of 400, which would be 20. So it would be x equals 20. So I'm going to stop here with this recording, and then I'll send out a couple more recordings on just a couple of different concepts as well for you guys to watch in advance, and a few practice problems as well. Hopefully this made sense to you guys. And email me if you have questions about the Pythagorean theorem.